This is the lesson for 9.4, creating residual plots. So first we need to understand what a residual is. You're taking notes on these things, right? So a residual is the distance between an observed value and the predicted value. This has to do with interpolation versus extrapolation. So interpolation means that we're making guesses inside the data. And if you remember, when we made guesses that was inside the data, we could compare it to what it actually was. For example, with the t-shirts, we said that the t-shirts, if you got like really close to the actual number, was a really good guess. But some of them were really far away. So we're basically, the residual is saying how far away is what we predict with the equation compared to what the actual or the observed value was. And what a residuals plot is it's a certain kind of scatter plot that goes above and below. A scatter plot of the independent variable of the, so that's whatever was already on the graph, of the x's, I'm just going to put the x's, to the residual values. So that's what goes on the y-axis. So it kind of looks interesting. And then the way that what we're going to do with those is we're going to analyze them by looking at their shape. So I'm just going to first show some examples of shapes that we would look at and what the shapes mean. So there are four kinds of things, well, two main things that we need to look at. So these are residual plots. Residual plots that could mean it's a linear relationship. Mean that it's a linear relationship. And then I'll show you some that could mean nonlinear. So we'll do that underneath. We'll do that. So the next underneath there, we're leaving some space. Residual plots that indicate non-linear. So things that mean non-linear relationships. So we're basically looking, does it mean linear or does it mean non-linear? And that's really all we have to look at. So how the plots go is across the x-axis is whatever your normal scatter plot x-axis looks like. So if it had marks like 1, 2, 3, 4, 5, and we compared it to that, then your residuals plot needs to have that also. On the y-axis would be the actual residual. So in other words, let's just say that the number that you guessed for 2, that we got with our equation for 2, was actually 3 too many. So that means it would go right there. Or let's say for 1, what we guessed versus what we had was 1 too little, so that's going to be down there. Or what we guessed for 3 was 1 too many, it's going to be right there. So these are examples. So if it went pretty evenly, some above, some below, just kind of everywhere, with no pattern, everywhere, no pattern, goes everywhere with no pattern, then this could be linear. This would mean that it could be linear. Or another weird one is we could have it look like this, and I'm just going to show you what it might look like. You might have, oh, and it might go ahead, like above and below. So like this. You might have some that just a whole bunch of dots above here and a whole bunch of dots below the graph. So some even above and even below. This could, so it's kind of like a flat pattern, not curved at all, a flat pattern. And if it's a flat pattern, it could be linear. If it's kind of everywhere with no pattern, it could be linear. But the nonlinear ones could look like this. So again, we have this kind of this sideways T-looking graph, and it could go like this. So it starts out kind of nice, like normal looks good. But then all of a sudden it starts to curve at the end. So like that. So at the end it's curved. So do you see how that kind of looks like a ramp above or below? So this is, so the main thing that makes this nonlinear is we can see that there's a curve. So it's curved. It's curved. And then notice that when we go further out on the x-axis, they kind of, it's tight first. It's kind of close together. And then it goes to spread out. Those are not things that we want to see if we're looking for linear. The last example of these is sometimes when you do these residual plots, they kind of just end up going like this, kind of end up looking almost like a parabola. And again, the big thing with this that we don't like is it's curved. We definitely don't like curves. And basically we can see that there's a pattern. The pattern kind of looks like it's quadratic, right? So these are the things we don't want to see. So these up here on the top, if it looks like one of these, it's linear. Down here is the main thing we want to look is if it's linear or nonlinear. So linear and nonlinear. So let's do some examples. We're going to start by looking at the one that they did. So this is what they're going to give you. They're going to give you an equation, and they're going to give you a table. Remember that these values right here, this is what we observed. So this is like what we actually watched. And then this right here is we're going to use the equation to get the predicted. So we don't need to do anything with these numbers yet. But in order to get the numbers in the predicted value, we're going to use the equation. So what they did is first you take the x and you put them in place of this x right here. Let me show you that again with a different color. We're replacing this x right there. So taking this number and putting it in place of that x. So if we did that on our calculator, 5 times by 0.5, we would get 2.5. And then you're gonna keep on going down the list. So then you're gonna do 10 times by 0.5 and we get 5. 15 times by 0.5, we get 7.5. 20, get 10, 25, get 12.5, 30, get 15. So you just keep on using this here, clear over here, with the equation to get our predicted values. So now we know what we observed. Like this is what we actually saw, but this is what we predicted. So now this is basically saying how far off we were. And it matters how, like, which direction you go. So how far off, you're going to do your observed minus your predicted. And for these, I beg you, please use your calculator. In fact, there is a clever way that we can use our calculator to do everything for us, and it makes life a lot faster and easier. So if this is enough for you, if you don't think you can want to do any more crazy buttons on the calculator, you don't have to. but this is what's going to make it very nice. Your calculator can do all these things for you. I'm going to attach another video to this, and then you can see that. Hey, this is a video for how to make a residuals plot with your calculator, or even just to simply fill in these numbers super fast without having to do a lot of work. So you start by making the first two columns L1 and L2 just like you normally do. So this is L1 and then this is L2, and you're going to type them in just like that. You can pause the video if you want to catch up with me, if you want to follow along, but you don't have to. So first you put them in. Then we're going to go to y equals. And you're going to type in the equation. So our equation right here was 0.5x. Remember, x is that button right there. We've got that. So we put in, so we went into stat, edit. So the steps were, put the numbers in. In fact, I'm going to write the steps down really fast. So those are the two steps that we've done. We put data in L1 and L2, and then we put the equation that they gave you, into y equals. Then step 3 is you are going to go over to L3 and then up. And then when you're up, so that's dark, you're going to find the button vars. So in L3, when L3 is dark, you're going to go to vars and then over to y vars, and then first one for function, I'll write this down, and then we're going to pick y1. So we're going to take that function that we put into y1, and then we're going to do parentheses, and we say, I want to put these numbers that are in L1, we want to put these numbers into the function that we put into y1. So now we're going to take, so to get L1 there, L1 is down here, so we're going to do, we did the parentheses, and now we need to do second one to get L1 and close the parentheses, and watch this. You push enter and poof, all those numbers are there. So you'll notice all these numbers are right there. Pretty snazzy, huh? So let me write down those. So here are the steps. So you're going to go into L3. I'm going to assume that you know to go into L3, you're going to go up where it's dark. Then you push, I'm going to push clear. So you're going to push vars, right? Then we're going to push the over arrow till it says y bars. So we don't need to push anything for y bars. Then we're going to push 1 for function, and then 1 again for y1, and then a parentheses, then the second button, then 1, and then close parentheses, and then enter. And then poof, the answers are there for the first column. So you can do this for all your homework problems. And then the last one is also very easy. So this is the last step to be able to fill in the table. So the last step, what you're going to do, and again, I'll write it down after I show you, is you're going to go up into L4. And to get L4, we're going to take all of our L2 numbers, and we're going to subtract L3. So when we're in L4, we're going to do L2, so I did second 2, then minus, oops, not times, minus L3, just like that. And there, it filled in all those numbers for you. So I'll write those down. Here are the directions, and I'll explain it one more time. So into L4 means we go up to L4, and then we're going to do second 2 minus second 3, and then enter. And then poof, we have it.